We're talking about some war stories from the trenches. Myself and my colleague Carl here, we're with Datadobe, and we are a company that has, we've been around since 2010, and the context of this discussion is about data mobility in between different platforms from different vendors and some of the complexities and some of the fun that we've run into over the years in doing a seemingly trivial activity about moving data around. So, as I said, we are your team today. Myself, I'm Steve, and Carl here is our CTO. What we're going to walk through here is a little bit, set the table a little bit, statement of the obvious material about file and object storage, why we even copy data, right? There's a variety of reasons for that. How we copy the data, what starts that snowball rolling downhill about complexities when copying the data. We'll talk about some scenarios, some basic scenarios, a little more advanced, more complicated scenarios, and then the war stories, that's where that'll come in for as we've gone through those types of projects, the things that we've run into along the way, and then the lessons we've learned as a result of that. So that's what we'll cover today, and we'll just kind of go ahead and jump on into it. File and object storage. And I guess the other thing I should mention here is that we're talking about this in the context of purely unstructured data. So, not really worried about structured data or block data in this particular conversation. So we focus on file and object. And if we take a step back and look at, file data's been around pretty much forever, right? I mean, we went from, it's been a while since we were pulling out our 8-inch floppies from our CPN machines and doing sneakernet around the office, because file storage and sharing over SMB and NFS saved us from all of that. And that's been around for a long time, and it's showing its age, obviously. Object storage came along to help some of that, right? So one of the big things with object storage is now we've got the metadata, right? We've got enriched metadata. There's only so much you can do with all the timestamps and the path names and the file names in the file space. So, object storage gives us a lot more capabilities with that. But there's also some more complexities in it, which we'll touch on a little bit later, as far as, things like object locks and worm has been implemented in different systems that are all, as I think I recognize some of you in some of the other sessions talking about S3, where systems are S3 compatible, that term that means everything and nothing at the same time. And then there's kind of a third category that's emerged the past few years. We have things like, Dropbox and OneDrive and Google Drive, and they kind of act like NAS in a way in terms of file sharing, but the data's all hidden behind, it's in a walled garden behind an API. And somewhat similarly, and we have more customers asking about this kind of stuff today, is what we call application captured unstructured data. So this is those SaaS applications, your Salesforce, your ServiceNows, your Slack, right? More and more companies are wanting to get to that information that's in those applications, extract it, catalog it, index it, and make some kind of use of it. So the definition of unstructured data is continuing to evolve, as a great many things do. So I'll touch on a second here about why copy data. You may be asking yourself, this is kind of a self-evident question, but there are there's quite a few scenarios for this. And, the traditional move of data between different types of systems, that's come as a result of like asset refreshes, right? We have customers that, they've been dependent on a certain vendor for a while. Now they want to try another vendor. We have other customers that say, okay, well, we've settled on one vendor, but we're going to start dual sourcing things. So they want to get other technology in, and then they want to spread that data out. So all their data is not locked into one particular technology. Cloud adoption, pushing data up to the cloud to file services or object stores in the cloud. That's been, we've seen a lot of that this year. And then conversely, and I debate this with analysts from time to time, because you would think, talking to the analysts, it's just a one-way street to cloud, but data does get repatriated, right? There are customers that have pushed a lot of data up to the cloud after their initial cloud pricing is expired, and as more data is accumulated, the finance people have gotten bills that have served as smelling salts, and then the natural reaction is like, we want to pull some of this back down again. So some people will say that, it's a one-way street, but we see otherwise, right? And that's actually spilling over into the geopatriation as well, right? So now there's issues with sovereignty. Where is my data? Which country is it located in? What laws is it subject to? That's another one where it's like, well, we've got to move data around, right? So people want to minimize data movement, but it's kind of like the mainframe. It's still alive and well, right? So there's many other use cases out there of data mobility. Data replication, one of them. I mean, typically, we use in-family tools, replicate in between like-for-like systems. But there are times, and we have more of our business is being built on replicating things where customers might say something like, well, we're decommissioning our DR site, and we want to replicate from our traditional vendor on-prem. We want to replicate that up to a cloud file services. We can't use the in-family tools to do that. So we end up getting into a situation where we can come in and fill that gap for a customer and replicate data in a cross-platform fashion, right? Data archival is something that's got a lot more interest now as people are starting to get visibility into, well, I've got 5, 10, 15 petabytes or 100 petabytes of data, and 60% of it hasn't been touched in 3, 4, or 5 years, right? It's like, well, let's get that off these platforms and put it in an appropriate location. Then, the AI pipeline, right? And we've seen that in the sessions that we've all been in this week, right? Moving through, going from the original source systems into the outer ring, going into the inner ring where the more higher performance storage is required, right? So that's another use case where data mobility is required. It's just there. Backup and data tiering are common use cases as well. So since we talked about, just the generals of file and object and, and why we copy data, Carl's going to kind of take over here and talk a little bit about how you copy the data, which it's beyond a little copy command. Might start that way, but it gets more complicated.
Thank you, Steve. So how to copy data? Well, let's think about what are the goals. So if you think of it, it's like, okay, we want to make it equal. Source should be equal to target. That's a very managerial statement. No questions asked, just make it equal. But how equal? Can you make it 100% identical? That's what people originally think. But if we cross protocol boundaries, even if we stay within the same software or the same vendor, it's close to impossible to make things 100% equal. And so look at a couple of properties of files and objects. So content seems like the most important one. The name, the paths, the metadata, advanced metadata. So let's look how we score on these things. So I would say content, I don't give it a green check mark. It's a yellow check mark. In most of the cases, you can make the content equal if you migrate data, but not always. Path and file name is already a bit more difficult, but most of the cases it would work. Metadata, most of the case it works, and then things start to go really south. So if you look at many S3 metadata fields or things like e-tag, storage class, the name of the storage class, retention properties, there's no guarantee you can keep all that stuff equal. And also for files, there's lots of properties, change time. You could judge like inode number is not a property of a file, it's an implementation detail. But there are crazy applications that depend on some of these fields. So now let's look at, when I joined Adobe, I thought, okay, well, how do you copy data? It's very simple, I'm very smart, so let's copy data, and the smart thing is I will do it multi-threaded, so then it's gonna go fast. Like, how hard can it be? And that's how everybody starts any kind of migration. And then you could say, okay, but yeah, you didn't copy permissions and timestamps. Okay, let's month CP. Okay, yes, we have a flag for that. We're very happy now. Might work for a static data set, but in reality, this thing is about copying hundreds of terabytes. Could take weeks or could take sometimes even months, we've seen. And if the data set is not static, it's changing, then you're going to end up with a completely corrupt thing. Files will be corrupt, files will be missing. So, okay, we make the source read-only, we do the copy, and then we point our clients to the target, which is, by the way, also a very difficult thing. You have to kill sessions with SMB, you have to unmount NFS, there's no good standards for that either. But again, now I've made my business application, my storage system, I've made it read-only for a week or a month or so. Unacceptable. It's too slow, not gonna work. Okay, let's add some rows to the script here. So we start with a full copy, but without being read-only, and then we do a lot of incremental copies, and then at a given point, we invent a thing called a cutover or a switchover, where we say, okay, let's now Saturday night, 3 a.m., let's freeze the system, do this final increment, hoping that this only takes a few hours, and then we point the clients to the target. So that's an option, and that's like the basic way to do migration. Still, it's too slow. It's too slow, so let's do a little trick. We skip all those files that are being created, because lots of incremental changes is about a file that's being appended to. So a file gets born very dynamic. It lives, it grows, people seek, people write, and only after a while a file stabilizes and slowly becomes an object. That's really how things get born. So you can, in a number of the phases, you can basically say, I'm gonna skip those recent modifications. It speeds up the whole thing and it doesn't do unnecessary copying. But of course, in the cutover, you cannot skip. It has to be read-only. You have to get it all. So now the next step is, okay, I want to estimate how long this cutover is going to take. So, well, again, another phase needs to get added. We call it a dry run, where you do the real full copy without skipping, and you report on that, and then you basically know, okay, I've spent a month with the full copy and a number of incremental copies. I do this test like representatively, 3 a.m. on a Saturday morning, how long such an increment would take. It takes me 2 hours. Then I plan for the next weekend, a 4-hour window where the systems really go read-only. And then I have a little bit of confidence that it might work. And that's how I can basically start to plan. But again, we missed the testing part. So there's all kinds of mess. People will actually try to test that target system. The target system might be too slow, might be misconfigured, the network might not work for some reason. So in the initial phases, even before you think about cutover, people will test the target. So they will, although the source system is the canonical truth at that point, they will still want to test the target, first read-only, but then even writing a little bit, just to clean the pipe, basically, to find out if you can put stuff on there. And then the continuous incremental overwriting should always clean it up and make it identical. But even worse, this can also happen at the end. You might say, okay, now I do my final cutover, I point all my clients to the target, and then there's a firewall. The client cannot talk, or this specific client cannot talk to that storage system, so I need to go back from step 8 back to step 2. The weekend has failed, let's try next weekend again. And we've seen all these things. You could think it will never happen, but it happens all the time. It's only when you do the real testing that you're certain that it works. And some testing you can only do with the real system, with the real volume of all the data, with the real application talking to it. So as you can see, migration is a highly non-plannable, non-linear thing. You need to do a lot of preparation before you can get to this, hopefully 2, 3, 4 hour cutover window that you plan. There's many other things you can read here that matter. You want to retry specific errors. You want to parallelize it, throttle it. It can go fast at night. It should go slow during the daytime. So there's plenty of extra to it, but the crux is it's a nonlinear process, and also it's not only from target to source, from source to target. Sometimes you need the opposite direction, because people will start using that target too early, accidentally, and then so you need really arrows in both directions for this. Steve, you're going to talk about a few of the scenarios here.
We'll walk through a few scenarios. Yes. Quickly. So we broke this into some basic scenarios and then some advanced scenarios. The basic scenarios, this is pretty much the square peg and the square hole conversation here, right? So, these are, full server copies, just pick everything up off the source, drop it onto the target system, and call it a day, right? Cross-vendor gets a little more complicated there because there are implementation nuances in between these systems. But generally speaking, you learn those pretty quickly and can work around those. And from a protocol perspective, you're really pretty much staying in your swim lane, right? You've got SMB data, those are the authoritative permissions, so that's what you're migrating, and then reprovisioning on the target system, and the same for NFS and S3. So those are all table stakes, and those are all things, I mean, there are certain complications with them, some of the things Carl just went through, but for the most part, this is all doable. Where we get into some of the more advanced situations, this is more square peg and a round hole material where, you have things like multi-protocol NAS, so this concurrent shared access between Unix and and SMB clients on the same content simultaneously, right? Well, how do we move that in between different vendor implementations? Because, SMB is somewhat standardized, right? And this works a certain way. Everybody knows how it works. And NFS has its RFCs, and what a lot of our customers assume is that, well, those are all standardized, so surely the multi-protocol implementation is standardized as well, and nothing could be further from the truth, right? If you deal with 3 or 4 different vendors that are on the floor, they all have 3 or 4 different implementations. And so it's a challenge to not only move the data over, for all those issues, but also maintain the fidelity of the permission so that the access behavior is the same or as close as possible to what was on the source. It's no small trick. So that's definitely a complication there. Things like file gateways, these are things that we have to dance around, right? Because you cannot just put a flamethrower on these things and just blast data into them. That's not what they were built for. So it's pretty much an issue for the most part of just maintaining the workload. But again, like how Carl described, run faster in the day or run faster in the night and run slower during the day, right? Well, you're going to be throttling everything, network throttling, thread throttling, in order to keep the gateway happy and not overload it. Compliance data, or kind of what we got here, is lock data, so data that is being stored in a worm domain on a NAS system, or if it's on object and it's object locks, or just on legal hold. Migrating this data, again, this is kind of similar to that discussion about the worm data, is that the multi-protocol data is because worm implementations vary, right? At the end of the day, the behavior is similar, but the way they're implemented is different. So when you're going in between different systems, you have to account for that. And that's some more complications there, since they are not all compatible. You're not going to get the same exact behavior. Granular data reorganization. This complicates migrations as well, where customers decide, you know what, I've had this system, it's been managed by a cast of thousands, the directory structures are ridiculous, right? So we're going to do a bunch of mini migrations, and we're going to redo the directory structures, we're going to reorganize the data in a more sensible fashion. But then again, now when it comes to permissions, right, maintaining that fidelity and the consistency of those permissions and behavior gets a bit more complicated. Plus, you're coordinating more activity with all, instead of one big migration, a bunch of little migrations. And then we visit the protocol change. So now we're getting out of our swim lane. I've got file data. I want to copy that to an object store, either on the cloud or an on-prem implementation. So I'm going between file and object, and the semantics between file and object don't always play just real nicely, right? There's some overlap, and there's some areas where it's decidedly different. So that adds complications into the process as well. And with that being, so we think of the context of some of these advanced scenarios, some of that type of thing that we're talking about, and there's a lot more from there, trust me. But Carl's going to walk through some war stories here, and then the lessons that we learned after we experienced all of the joy of going through these systems, going into them naively, thinking we would knock them out.
Thanks, Steve. Good. Are you ready? So it should have been easy, as we all thought, but let's have a look. First of all, sometimes our biggest enemy is the customer himself. They misconfigure things. They try to lie even sometimes. That happens. So, like migrating to a non-empty system, we need to protect against that. having automatic retention on the target. So whenever you write an object, it's undeletable for 100 years on some systems. So you need to warn them, because that's often not what they want. But it's in many systems, it's a feature, both on NAS and S3. A cutover is needed because people might start using that target too early and put business critical data on the target while the migration is still running. It happens over and over. So a migration should be hyper paranoid, and if it sees a change on the target that it didn't do itself, it should like stop, because you might create data loss if you keep synchronizing. Unfortunately, this happens. When this happens, you have some canonical data on the target and some on the source. So it's, in one case it could be data loss, and in another case it's a split brain with two truths, and you have to like find out yourself what it is. So you need to avoid all these things at all costs. Configuration-wise, we see very often people access the wrong server. I mean, in protocols like NFS, if the paths look very similar on systems, or with S3, if it's the same credentials used in different buckets, there's no real immediate check that you're doing the right target or the right system. So you need extra checks for that. Proxies make it even worse. They put a proxy in between, like the security guys, the storage guys don't even know about it, and it points to somewhere else because of a misconfiguration. Good old friend DNS. So these two URLs, people who know S3 will say, yeah, this is path-based and virtual host style. In many of my customers, I end up on a different server with these three things because they use etc hosts or something to do bucket.s3.company.net. So this happens way too often. And of course, think why this virtual host style is good for cloud services like Amazon or Google or Microsoft, but for on-prem, very often you don't need it. So the virtual host style is actually sometimes unsafe, and the path style might be safer. We very often see you cannot enter a subdirectory. So you're migrating like, let's say 50 million files, but a few subdirectories, there's different access permission, and the account with which you're migrating doesn't have access in there. Could be NAS permissions on the directory, could be a bucket policy on an S3 bucket. So there again, you need a way to not stop completely, but to granularly flag like there's a problem in this subtree, and then you can retry that subtree in isolation so that the whole project doesn't take months to do the migration. Credentials, so we recently had an interesting case where IT didn't get the credentials anymore of the bucket. So there was a big financial institution where they let the departments manage their own S3 buckets. So IT, the only thing they do is like look at the bill and put lifecycle policies on there. But the departments had the S3 credentials and didn't want to share that with IT because it's their data and they're very secretive about it. But then IT is asked to migrate. So now you need to find a system where the departments can somehow communicate the S3 access key without giving it to IT, but giving it to the software and so on. So these are all complexities that are happening in real life. Timestamps is an absolute nightmare. So the idea of making a target identical to the source, what is happening is that very often you write data, and 1 or 2 seconds later the timestamp flips. It goes up a few milliseconds or seconds. In one case, we could pinpoint that to antivirus running on the target asynchronously and updating the A time. In another case, we still don't know what happened. The vendor didn't want to help us and tell us what happened, but indeed, we could prove with the logs that timestamps were changed a little bit, a few seconds after migration. So if you then try to synchronize, the whole thing screws up and it keeps synchronizing. So you need to get some like lenient rules, like what does equality mean? What we also see very often, listing data like directory or a bucket versus looking at an individual file or object with stat or with head object, you get a slightly different timestamp. It might be granularity, like second versus millisecond, but even worse, if you look at the example there, it's not rounding off to 12.12.01, it's rounding weirdly to 12.12.02 or even 12.12.03 we saw ones, like it rounded up 1.5 seconds. And then we still need to consider that equal. So you need to have like rules like, okay, for me 2 seconds difference is still the same, so I trust that the content is still the same if you look, for example, at the change time in NFS. And certain things you cannot set. S3 modification time, there's no API to set the last modified. Change time on a file server, there's no API to set that because it's a built-in thing. For good reasons for some of these things, but for if you like, try to migrate S3 and you cannot keep the last modification time equal, it's a problem for systems. It's like lifecycle policies are totally screwed up. Retention might be screwed up. The source A time is very interesting. If you do it naively, you read the source data, copy it to the target, but you've actually changed the A time because you looked at it. If you look at a file, you change the A time, and the A time might actually be the metric to say if your data is hot or cold. So you might totally end up with, I've migrated everything and the change or the access time is like whatever, last week, so all the data is very hot and the lifecycle policies cannot evict it for another year or so. So that's not the intent. So you need to be aware of access time. M time, oh, this was an ugly example. Microsoft Word, I believe, or one of the Office tools. When you open a Word document without editing, it opens it. It writes in the XML header the new M time content. The file M time is also modified because of your file system seeing a change, but then Microsoft Word is resetting the file M time to original. So semantically, there's no change to the file, but if you calculate the MD5 or another hash, the content has changed. So these things happen all the time. So people because there's APIs to change M time, so people do that. So time is a difficult thing for sure. Names is probably even worse. Length limits. So we have maximum, like pod max, I know it's 4096. Max pod used to be on Windows 254, now it's 65,000 characters. S3 has a limit, 1024 UTF-8. Azure Blob has interesting constraints, like you can have no more than 254 slashes in an Azure Blob pod because they internally segment it up in, it's not really a directory structure, but still it's a tree. So you can see there's like 1 byte of tree depth, I guess, that in the implementation. So all these things are okay if you stay within the system, but if you go cross-vendor, you can see some things are not migratable. Illegal characters, all dependent on protocol, what is allowed, what is not allowed. Yeah, this is really funny. So in illegal names, there's like legacy Windows names from very, very long time ago. Clock dollar, I didn't know about that one. File space is not allowed. S3 also has their set of rules, like a file name or an object name should not look as if you try to escape your own bucket with too many dots. Very big problem is object keys ending in slash, because if you would migrate that back to file, there's no way you can store the thing on NFS. And then very funny, try to put an object with name SOAP on S3 Amazon, it's not going to work because of a legacy 2005 SOAP API they had. But actually there's tricks to do it with what is it, path name style and so on. You can still do it. This is really bad, so the case sensitivity, especially multi-protocol, you might have project lowercase, project uppercase. In NFS, it's 2 different files. In the SMB view, it's 1 file. They might actually create this 8.3 naming, you know, project tilde1, project tilde2 things, which are dependent on the order which you created. Like the first one, who's like a collision, would get the tilde1, the next one tilde2. So that all is very problematic if you try to migrate because you hardly know what you have in your hand. If it's a directory, it's even worse. You don't know which directory you're in. Encoding. We see this very often in Europe. So if you migrate, you might end up like Muller, four ways of spelling that word. So migrations are often total failures because of weird non-ASCII characters not coming through correctly. So why is that? So, well, in a source server, a name is stored as bytes. It's byte. Let's say it's NFS v3, that's the simplest protocol. It's just bytes. And then to interpret these bytes in, I would say, SMB, S3, Azure Blob, there's a decent description how to interpret bytes, like as UTF-8 or UTF-16. But in NFS v3 there was nothing, because this predates even the Unicode concept. So you need a way to translate that into a canonical truth, what it means, and you could use Unicode to describe these characters, but still you need that mapping, and you cannot just retrieve it from the server. There's no API to ask what is your file name encoding, and then you need to encode it back to your target, which might be UTF-8 or something. So, and these arrows also need to work in the opposite direction in some cases, because if you do a premature writing to the target, then you need to resync that back to the source, and that's really often problematic. So you've seen all these encodings. So I found this funny quote here: UTF-16 is a dumb, useless hack, and UTF-8 is a brilliant, useful hack. That has to do with the fact that UTF-16 it's a bit like Bill Gates saying 640 kilobytes of memory is enough. Unicode started with 65,000 characters is enough, and then we started to combine smileys in chat. So. So UTF-8 is indeed aware of more of these characters, and but still UTF-8 also has problems. There's like byte order markers, overlaw encoding, zeros, problematic code points. There's a recent RFC, it's worth reading. A very cool project I found, WTF-8, is like a project to fix some UTF-8 problems of unencodable things, because my arrow has to go up and down, and in some cases, if you put in UTF-16, if you put unpaired surrogate halves in the wrong order, they are illegal, they are not translatable, but still if you migrate between systems, you might just want to copy the bytes as bytes, and you don't really care about the canonical interpretation of the bytes. So WTF-8, you should look at it, it's good stuff. Limitations, number of files per directory. I mean, most systems come to a halt at a few million files per directory because of the way they organize, the way the APIs are to list directories. Number of inodes might be limited. Files are mutable. Files might be locked during a migration. Yeah, let's have a look at object storage now. Object storage built on top of HTTP. You might think a 200 HTTP response, that's a success. That's what we all learned. But HTTP is a very open standard. So let's have a look. So I do this. What is it supposed to do? And then I gave the example of wrong DNS in the past there. So this is supposed to list my bucket content. So this is the good result. You got the list an XML document with the. But if you're unlucky, if it points to the wrong server, you get a list of buckets. It's again a 200, and it's actually correct, but it thinks that it's not allowed to cut off like some part of the host name, and it gives you this. We've seen that very often. Even worse, I've seen this. HTTP, just an HTML page that comes back. And many of these, even SDK implementations, might not even give an error. It's only when you really read deeply that it says, okay, this is the wrong XML tag that I find here, if you're lucky. Another example is multi-delete. So if I delete a bunch of files at once, I can get a 200 response. You think it's a success, but actually the body of the 200 tells me, yes, I've done the call, but this object could be deleted, this object could not be deleted. So you really need to be, I mean, it's not like programmatic APIs. This is much looser, I would say. SDKs do a big deal of the work, but not everything. This is a problem we saw recently as well. So if AWS S3 evolves, there's a concept of sub-resources. And you might, for example, put a sub-resource, new feature I called it, on an important document. Let's say things like tagging is a sub-resource or retention. And the server could say, it's okay. But if I then get the object back, I might just get the sub-resource content because the server ignored question mark new feature. So it ignored the query string because it's an older server that didn't have this implementation yet. And this might override the object. So I actually have data loss. So my poor engineer is in trouble here. So this is a real problem with respect to forward compatibility for the storage vendors and the implementers. A head response has no body. So it's very difficult to find out what the error was. There's very much ambiguity. Should a put return a 200 or a 201? I've seen a delete is even worse. 200, 204, 404. Is it idempotent or not a delete? So there's like we've seen all the possible implementations of various vendors. E-tag, most people think it's an MD5, and for a simple small object, it is an MD5, but in many, many cases it's not. If you use encryption, if you use multipart, there's no guarantee at all. And a S3 version ID, just like timestamp, is not settable, so it's very difficult to make an equal system. The content limits on size, limit on metadata size. SMB is funny. You might put 3 files in a file. It's called alternative data streams. If you migrate that, or let's say archive it from SMB to S3, what do you do with these alternative data streams? If they're big, you cannot store it as metadata. They're too big to make second or third objects that then your object count doesn't match the file count anymore. Eventual consistency is a problem. And also what we do very often is when we write data, we always read it back, because you might, I mean, the system might say protocol-wise, yes, thank you, we've received the data, but you cannot trust that. There might be network problems, there might be bugs in the storage servers. So it's a default feature. You write to the target, you read it back, and you compare, for example, the hash of what you read on the source, what you read on the target, to declare equality. Multi-protocol, yes, we've talked about this one. So with directories, it's even worse. There's an uppercase dir and a lowercase directory, and if you enter the path, you might just be in the wrong subtree without noticing. And with NFS, it's more clear. With SMB, again, this might happen. This kind of path, if you migrate it from object to file, there's 3 objects created, 2 directories and an object. But if the opposite, if you migrate it from file to object, same problem. Some object storage systems will actually create these my slash as an object, the 0-byte objects. My slash, cool. So what we heard about Vast had a presentation earlier today, is that these things should all be stored correctly as metadata, and you should know, like, what are you really trying to do? Is it supposed to be an S3 thing? Is it supposed to be a file thing? But so there are all these side effects that things get added behind your back to the system, and then if you delete the document, you might have the 2 0-byte things left on your system. And stuff might simply not be copyable. If my cool project slash has real content, it's not copyable to NAS. There is no way to do that. So let's now talk about lessons learned for a few of the players, like the people making data management tools, the people making storage systems, the application people, and the storage administrators, because they're all involved with this. So looking at ourselves, so data mobility software, you need to be very careful, very defensive. You cannot trust people or protocol specs or servers. So whenever something's weird, stop. Don't make sure you never have data loss. There's process mistakes, people mistakes. That happens all the time, so you need to be extremely careful. Old storage systems, so if you migrate, it's typically this unsupported 15-year-old storage server that you need to copy to some new system. The vendor will not help you either, so you will need to build quirks and software around these problems to be able to read data. The specs are very interesting because they not only document how a system works, but they also sort of document how it's built. There's always hidden hints, like there's a limit on this size, so probably there's a buffer there, or there's a queue, or we should be careful not to overload that. So you need to read it. I need to read it again so that you're in the mind of the developer who built that storage system, and then you can avoid certain mistakes, or at least be defensive and proactive and have the proper logging. Storage system developers, that's even more difficult. So of course, yeah, have enough logging so that people can find out what went wrong. Input sanitization is critical, and this is especially important here for S3. So unknown HTTP protocol headers, or headers that are in standard HTTP but that you don't support, like conditional put is a new thing in S3. If you ignore that, it's data loss. It's plain data loss. Query string parameters that you don't know, you've seen the example where it could lead to data loss again. So what you really should do is, like, everything that's unknown, you forbid it, and then in the GUI you have a way to whitelist and open up again, like, okay, you can have this x-amz-something. You can safely ignore it, but it's a deliberate choice. The default is safe, no data loss, no data corruption. Data mobility is a problem if like settable credentials for S3. There's almost no system where I can choose my access key. The system will generate the access key, but sometimes ideally people want to do a DNS change and they point from the old system to the new and it works. Like with NFS, if there's an IP address change, it's supposed to work. A fast way to get a full inventory of a system, I've heard many teams doing that. I know, Google, Azure Blob, Amazon, Vast, they all have like inventories plus incremental ways to say what has changed. I particularly like at Google, there's like not only a data version, but also a metadata version number that you learn the metadata has changed. It might point to like, okay, maybe the retention has been bumped or something. So that's all very helpful to make the whole incremental path fast enough that you don't do useless work here. And yeah, new thing here earlier this week, S3 RDMA. So there's dialects popping up. So we should be aware what it means and what it. Like if they write a 100 megabyte file, but it's actually a 0 byte HTTP request, and they sign the 0 bytes, we should be very aware of what we're doing at that moment. So SNIA is doing plenty of good efforts to get this compatibility, both SMB, S3, both test suites and Plugfest. So this is really very helpful for this. Application developers, of course, test against various storage systems, but also avoid trouble. So keep things small. Don't put 254 slashes in your key. Don't put weird smileys in your object names. Don't put Unicode in your metadata fields. Don't have like exactly the 8 kilobytes of metadata that Amazon sort of allows. Don't do that. Don't put ... or slash in your... Don't do all that stuff. Never assume that a server understands what you're doing. So always look at the response, parse the response. This is making noise, Steve. And both success and error responses you should process like diligently and be sure that the server has understood what you're doing. And as I said before, don't use all these custom HTTP headers or try to sidecar some metadata on there. It's dangerous. Very new features, conditional put, have a fallback path, understand that the server doesn't understand you, and have a secondary path, which might be slower or less transactional, but you can do that. And last but not least, the storage admins. So, test the combination of application plus storage system, even if it's a new one you're going to. Don't assume today, we want to get there one day that if it says we do S3 that it really works, or we do SMB or NFS, but you still need some testing. Scaling and performance is very difficult, like file versus object. It's a different history, different purpose originally at least. Data mobility, so at some time your system will be old, 10 years from now, 8 years from now. So you'll need to migrate it to something. Maybe the vendor will help you if you stay within his family of systems. Maybe you want to go to another system. Maybe you have to go to another system because you're like your company is acquired and the data centers are merged. So think of mobility, and especially if you use tiering, gateways, or all kinds of fancy stuff, it only complicates these things tremendously. And all the storage vendors have very specific cool features, but it complicates the interoperability. And finally, when you do this migration or cross-vendor replication, don't assume it's simple. It's not just a script. Everybody thinks it's just copy star dot star, but in reality, it's much more complicated, so should be aware of that. Thank you very much. Any questions?
I never want to copy anything.
That's okay.
Could you explain a little bit more the conditional put? I haven't heard that one.
Yeah, conditional put, so that's a feature. I don't know on which slide it is. It's a feature where you can say like, write this object if it's not yet there. So like if the object is there, you don't overwrite it. But if the object is not there, you can say like, okay, you can put it. So it's a little bit transactionality. It's exclusive somehow from the NAS world, but then for S3. And if you ignore these HTTP headers, if non-match and so on, if you ignore that, you will bluntly overwrite the object in any case, which I call data loss. Of course, you might have versioning, which then sort of you still recover the object, but that's the case. Other questions?
For metadata that you can't change, like timestamps, do you ever take advantage of extended attributes in the file systems or user metadata in S3 to like write your own metadata to help you with the migration?
So the question is, what about metadata fields that you cannot change? So yes, the answer is we copy that into other attributes. Like, for example, if you go from NAS to object storage, lots of, like the owner, for example, or the ACLs, you would store that as user metadata fields. And then in a future restore back from object storage to NAS, you can revive that if you want, if it's still meaningful, of course, because it might be years later. So indeed, there are mechanisms to store these things. I think NFS v3 probably has nothing, but most other protocols have something to do that. And that's important because metadata is data. It's after all, it's also some of the things like version ID and timestamp. If you go S3 to S3, you sort of lose it, but you can still store it as metadata. And then if applications would understand that, you could at least build policies on top of that, or restore it, recover it at some time. But I think we might need, with the SNIA group, some standard, especially for these two S3 timestamps and S3 version IDs, because it's something that should be able to stay compatible across replication or across migration. Anything else? Thank you very much.